So let's talk about macromolecules. So do you remember when we were little, we used to play with Legos, and Legos had like so many different types of blocks that we were allowed to use to kind of build whatever we wanted. So I actually hated Legos. I never understood the purpose of it, but I guess I was supposed to learn how to do macromolecules or understand macromolecules, right? So we happen to have 4 different macromolecules in life. We have carbohydrates, right? We have lipids, we have proteins, and we have nucleic acids. So all this is saying is that we have 4 different building blocks that we can mix and match in life to create bigger organisms. So let's talk about carbohydrates first. Just like the word suggests, carbohydrate. It is made up of carbon, hydrogen, oxygen. And it just so happens to have a very special formula. It's a 1 to 2 to 1 ratio to the n power. Okay, so I kind of memorize it as Mr. Cho is a very sweet guy. All right, and Mr. Cho, because he's a very sweet guy, we like to know where he lives, and he lives in 1 to 1. So carbohydrates is sugar, okay? And sugar happens to give people an immediate source of energy. And I say people, but we're talking about, organisms. So immediate source of energy. Now, let's talk about its monomers and polymers. So the monomer, it has a very special name, and we call it monosaccharides, okay? And monosaccharides are the smallest sugar molecule for carbohydrates are C6H12O6. And this is going to be one tiny molecule, a monosaccharide. Examples of monosaccharides are glucose, fructose, and galactose. Make sense? All right, so these are all isomers of each other. But remember, our body only likes to digest glucose. So if your body consumed fructose or galactose, what it's going to do is it's going to rearrange itself to make fructose and galactose become glucose. All right? We also have disaccharides. So if you guys remember, disaccharides are 2 monosaccharides put together. So I'm going to now put 2 monosaccharides together. And there is a special covalent bond called glycosidic linkage that will be holding them together, okay? And examples of disaccharides are going to be sucrose, maltose, and lactose, all right? So sucrose is composed of glucose plus glucose, right? And sucrose, I got a little excited. Glucose plus fructose will make sucrose. Glucose plus glucose will make maltose. And glucose plus galactose will make lactose. All right? Okay, cool. Now let's continue. Let's talk about polysaccharides. So polysaccharides, for the first time, we are now going to be actually gaining some real function. But remember, guys, animals and plants are a little bit different. And so the 2 types of function that we like to kind of memorize for the sake of polysaccharides is structure and storage. Okay, so we like to store glucose molecules in our body because we need to kind of use it. So as animals, we are going to be storing it in the form of glycogen, and we store it in the liver, okay? Plants, they like to store glucose in the form of starch, and they kind of like to store it in the roots, unless you're pasta and I don't know where you store it, okay? All right, for structure, animals, it's going to be chitin. Please don't call it chitin. Sometimes people call it chitin, and I'm thinking, why are you shitting me, right? Anyways, it's chitin, and you will find this in the cell wall of fungi, but also in the exoskeleton of insects. Okay, and then we also have cellulose for plants, and cellulose is going to give a plant structure. And it's basically, in other words, fiber. And our body cannot break it down because it's glycosidic linkages. It's just so special that we just don't have the enzyme to break that glycosidic linkage. And so cellulose comes out through the other end because we cannot harvest the glucose molecules. And that's it.